All right, on number 24. So this one I actually didn't realize you need a little bit more knowledge than we've had at this point to fully answer this question. However, if we look at just the first two answer options, we can confirm which of these are true and which are false, which we're asked to determine which of the following is false. With the first one, the limit as x goes to 1 of f of x. So we would look at the limit from the left and from the right. It should equal 0, and you can see that it is equal to 0, right? It's approaching 0 from both directions. The actual function value isn't that, but it doesn't matter, so that's true. The limit as x goes to 2 of g of x, that means if we approach from the left, it's going to be 1. As we approach from the right, it is negative 1. So that is true because the limit does not exist. The last two actually need a little bit more knowledge that we haven't learned yet. The correct answer is C, but I'll make sure on your actual test you don't encounter something like that. And then the next question actually has some terms we haven't learned yet that are in future chapters when it talks about being differentiable. So you won't be able to fully answer this one as well. Sorry I didn't do a good enough job checking your answer options here. But we could at least, maybe narrow out a couple of them here. So with this one, we're supposed to determine if it's continuous or differentiable. If it's something that's continuous, as we talked about the definition earlier, it was the limit has to exist, the function has to be defined, and then the limit has to equal the function. So if we were to find the limit as x goes to 3 from the left, that's going to be the less than 1. We would just do 3 squared, which is 9. If we do the limit as x goes to 3 from the right, we do this one, the greater than or equal to. So it'd be 3 times 6 is 18, minus 9 equals 9. So the limits from both sides are equal. So we could say that the limit as x goes to 3 does equal 9. So that's the first check. The second check would be f of 3 would be defined. We plug it into the bottom one because that's the or equal to. So we just get 6 times 3 minus 9. So we get 9. So that's a check. And then the limit as x goes to 3 has to equal f of 3. And that is true because they're both 9, so that's a check. So it's definitely continuous. So we can cross out that one. Cross out C because this is not continuous. Cross out D. So you narrow it down to B or E. And then we have to determine if it's differentiable. Again, we haven't talked about that yet. However, this one is differentiable. So it is E. Don't worry about that, though. That's the next chapter, actually. We get to derivatives. All right, and our last question here. Given a piecewise function, which is false. So let's just take them step by step. Continuous at 1. So if we're less than 1, we would get, so if we get a limit as x goes to 1 from the left, we would be 1 squared plus 2 times 1, so that would be 3. Limit as x goes to 1 from the right would be this function, because that's greater than 1. That would be 3. And then the function value, f of 3, actually, f of 1 is 3. So that's actually good. It is continuous at that point. Second one, f is continuous at x equals 2. So same deal. Now 2 actually isn't mentioned anywhere on these breakdowns, which means we'd actually just use this function sort of for all 3 cases. Just make sure it's a real number. It would be 2 cubed plus 2 squared plus 2. All it matters is it's a real number. In this case, I guess it would be 14. So it exists. That's good. Next one, f is continuous at x equals 3. For that, we have to do our different cases here. So limit as x goes to 3 from the left, we would use this function up here. That would be 27 plus 9 plus 3. So it's going to be 39, right? Yep, 39. As we go to the limit as x goes to 3 from the right, that means we would use this bottom one because it's bigger than 3. That's going to be 2 times 3 is 6 equals 7. So you can see the limits don't match there. So therefore, the limit equals D and E with that one, which means it cannot be continuous. So this one is false. That's got to be it. You could just double check f is continuous at 4. Well, for that, we would just use this bottom function for all 3 cases. So it would be continuous. It would be defined. It would be 9. So C is the wrong answer. All right, that does it. Hope you guys found this helpful. Reach out to me if you still do have any questions. I'm going to put your actual test on Edulastic. I think I'm just going to copy and paste them because I know a lot of people had trouble with the AP Classroom website, and I haven't heard back from the tech department yet on getting that installed. So I'm going to try to just copy and paste them on Edulastic and see how that goes. All right, see ya.